Hello, welcome. Good to see everyone. So I really love vocoders. I don't know if anyone here knows what a vocoder is, but that's okay, we'll go into that. Russell and I built Daft Punk's vocoder as an audio plugin, and I'm assuming everyone here is going to know some of those words, but maybe not all of those words, so we're going to cover that. Firstly, who are Daft Punk? You probably all know who Daft Punk are, but just in case you don't, they're a French music duo who wear robot helmets and make robot music, and they typically feature robot voices, robot singing in their songs. They're super famous. Even the Minecraft people know about them, so Technologic is one of their songs. What's an audio plugin? An audio plugin is a way to process audio. So it might be adding echoes or reverbs or whatever else. This is what we're trying to build. So this is what Russell and I attempted to build. Well, you'll see if we succeed or not later. Next up, what is a vocoder? This is probably the one most people don't know. I don't know if anyone knows what a vocoder is. What it does is it combines a voice and a synthesizer, and it turns it into a robot voice synthesizer. It doesn't have to be a voice, it doesn't have to be a synthesizer, you can kind of put anything into it, but for the purpose of this talk, we're just going to be talking about a voice and a synthesizer because it makes things a lot easier. The way it works is it analyzes the voice and it works out the frequency response, and then it applies the frequency response to the synth. So it's a little bit like the graphic EQ in iTunes, oh sorry, music app. It's very similar in that it works with, a lot of vocoders work with little frequency bands, and then they apply, that's how they filter the synth via the frequency band. So it's like the graphic EQ in the music app animating really, really fast to match the vocal. That's how it works. Now we're going to have a listen to a sample, so you know what we're talking about, and hopefully the audio works.
There is a game of love. There is a game of love.
So that's a recreation from Daft Punk's latest album. We're not going to go into lots of detail here, but this is the unit that was used for that example. It's super rare. The highest serial number I've seen online is 40, so they probably made about 50 of them. The picture you're looking at is the exact model Daft Punk used for their latest album. The serial number of that was 21. Ask me later if you want to know how I know all that stuff. Doesn't matter. We've got to move on. So vocoders commonly use lots of bandpass filters. You can build them with fast Fourier transforms, if anyone knows what that is. Doesn't matter if you don't. There's another method called linear predictive coding that can also be used. This is the interesting one we're going to be looking at today. It was initially created, this technique was created for cell phone telephony, I believe. And it does the same thing where there's an algorithm that figures out the frequency response of the input, and then you can use that to filter something else. This model, the DigiTech Talker, uses that technique. It uses linear predictive coding, so we'll have a listen to that.
There is a game of love. There is a game of love.
So it probably sounds kind of similar to the other one, to most people. It's a little bit crunchier. This is a digital technique. The other one was analog. Let's find out what a DigiTech Talker is. So firstly, this is the sound of Daft Punk, this specific vocoder. And that was unknown for a very long time. Here's all the songs. These are just guesses. These are my guesses. Here's all the songs I think that use the DigiTech Talker from Daft Punk's catalog, as well as a Night Call by Kavinsky, because that was co-produced by Guy Manuel of Daft Punk. I don't know if you know, that song was in the Olympic Games recently. I think that's why it sort of blew up, even though it's an older song. But now we're going to take a bit of a detour. We're going to talk about share. Here's share in a share sheet. Here's share in a share sheet by the seashore.
Hey!
All right, I'm sorry. I had to do that. Anyway, so Shares Believe came out in 1998, and it not only was it a worldwide smash hit, went to #1 everywhere, it also included a really unique vocal technique that no one knew about. Everyone was wondering how they did it. And here's an interview with one of the producers. And as you can clearly see, they said they used a DigiTech Talker. So that's the vocoder you just saw. Now, this is a bit of a conspiracy theory, or it's my theory on how this all played out. So Believe was released in 1998. There was an interview, and this is back in the days where there were magazines and there weren't that many magazines, so Daft Punk probably read the interview, and they were working on their album at the time, the second album, and that was released March 2001. So I'm thinking they probably read the magazine, they're like, this is what Cher used for her song, and it was really cool, and it's a great effect, and everyone wants to get into this. So I think that's when they bought a DigiTech Talker. However, this was a lie. This did not happen. The interview happened, and that's what the producer said, but the producer was lying because he didn't want to know, he didn't want anyone else to know how it was done. And in fact, the article now includes this comment, which says it was a lie. So the technique that was actually used for Cher's Believe was auto-tune, which is now really well known, very famous. Everyone knows how to do it. I think T-Pain, like half of his songs use it or whatever. It's very common. But back then, no one knew how this was done. So Cher's Believe used auto-tune. Daft Punk also used auto-tune. So I think they read the article, they bought the thing, they figured it out, and they're like, this doesn't sound the same. This isn't it. And then they figured out what it was, and they used both on that album. So anyway, that's my theory. I don't really have any extra evidence to support that. Could be wrong. Yeah, Daft Punk don't answer my emails. So now the DigiTech Talker, it was only found out in 2018 that this is the unit that Daft Punk used. And so Randy Goff made this post on Reddit, which is now famous amongst vocoder circles, because this is when it was actually worked out. Also, something happened with him, and you can look that up. I'm not going to go into it. Now, so the DigiTech Talker has never been confirmed by Daft Punk as the thing that they've used. And in 2023, so after I wrote an article, we'll get into that in a second. I wrote an article about all this stuff, and I've been talking to a whole bunch of people who are very into Daft Punk. And someone sent me this video, and they're like, can you identify the equipment in it? And I'm like, oh my God. For the first time ever, this is 2023, so this is, I don't know how many years of whatever, I'm not going to do the maths. There it is, right there. That's the DigiTech Talker. And I think Daft Punk didn't want people to know this, but it was in one of the sessions. They were not part of the documentary. They were not in the interviews. They don't talk about using it. It's just sitting there on the desk in one of their sessions, and it was used for that album. So there you go. Yeah, as I mentioned, I wrote a very long article, and I don't know why, but I just sort of fell down this rabbit hole, ended up researching all of this stuff, which is fun. And I bought a lot of equipment, and these are not even vocoders. These are all mine. This is my photo. This isn't even all of them. And yeah, these are harmonizers, not vocoders. We're not talking about them today. These are vocoders. I bought all of these too. Yeah, we are talking about these today because they're cool. I also, oh, okay. You know, sometimes on like eBay or whatever, you see listings where someone has cut out an ad for something from a long time ago and they're selling it. And you're like, who would buy that? Why is that even on eBay? So this is a promotional flyer for the DigiTech Talker. And I bought this. So now I'm the kind of person who buys that crap on eBay. And again, looking at this, I was like, wow, I can't believe it. The model shown is not the production model. So this is the flyer they sent out to the shops to say, hey, do you want to buy this new thing? And it's a guitar talker. It's not a talker. And you can't really probably see, but there's the actual program names. So the features are different on this flyer to the actual production model. I'm like, that's amazing. That's really cool. That's a bit of history. I don't think anyone knew that. So on the left is the production model, and on the right is the prototype. Oh yeah, these are both mine. I saw a listing, and it looked like, sometimes you see listings for old equipment, because this stuff's from a while ago and it's damaged and someone will swap parts over. And I saw the listing and I'm like, oh, this is someone who's had the thing and they've like broken it and they've swapped out the knobs for different knobs. And I just paid no attention. And then I saw it again like 2 weeks later. I'm like, hold on a sec. No, look, that's a prototype. That is like the only one in the world. Anyway, so I bought it. and it has different programs. It sounds different. It does stuff that the production model doesn't do. We're not going to talk about it today, but I've pulled them apart and we've copied firmware and swapped the firmware to see what, anyway, whatever. You can ask me about that later. So I had to go, because this is a very unique technique for making a vocoder. I had to go doing it myself, whatever, GPT, blah, blah, blah. I'm an okay developer sometimes, kind of, but not really. I probably couldn't get a job anywhere as a developer, but for making simple stuff, I can, sometimes get away with it. I tried. I definitely failed. I failed abysmally. And the next day I said, hey, Russell, I tried this and it didn't work. And Russell said, well, that's cool. Maybe I can help you. Except there's another problem. Our Slack history only goes back 90 days, and this happened like 92 days ago. So we're liars as well. This is all completely fabricated. Anyway, now my portion of the talk is done, and we can hand over to Russell.
Thank you, Marc.
Because it gets a bit technical from here.
That was amazing. Yes, so Marc, I got to tell you that Marc is a massive audio nerd, as you can tell. Vocoders, like audio, music. I think he's even produced his own music that you can find on Spotify if you look hard enough, maybe. He gets massive royalty checks from that, I believe. No. But anyway, to contrast that, I know absolutely nothing about music. I'm not at all musical. I've never played an instrument. I do not understand vocoders or anything. And Marc was talking about this, and I'm like, I don't understand any of these terms. Like, I don't understand what a vocoder is. I've never done audio plugins. I've done a lot of UI development in my time and other stuff along there. So I'm like, you know what? I have no idea what I'm doing, but let's give it a go. So I looked into it and I'm like, well, how do you make an audio plugin? Well, numbers go in and I'm like, I know numbers. And then you do some maths and then the numbers come back out. And the numbers, depending on the format, are something like, -1 to 1, and you get all the ranges in between. Like it can be 0.32 represents like a bit of audio, and you get a whole bunch of samples and you process them. I'm like, numbers are fun. I can do numbers. That doesn't look that hard. And then I looked into, okay, what kind of audio units do you get on the Mac? And there's one on the Apple platform called AU Audio Unit. It's up to version 3. I don't know what happened with the other 2 versions, but we're at 3 now. And it's really easy. You just make an extension in your Xcode project. So much like you'd make a widget or something else similar, you say, hey, I want a new extension. There's a template in Xcode. You get an audio unit. I'm like, okay, we're good so far. I think we're good. And I'm like, all right, what else do I need to know? Well, you've got to subclass this thing called AU Audio Unit, which, I mean, you're probably familiar with subclassing if you've done any sort of programming before. There's an initializer, there's input buses, there's output buses, there's a rendering block. I'm like, I don't know what that is, but I think that's maybe where you process the maths. There's some things you report back to the host application that you're running in, for example, like Logic or Reaper or like Ableton or other sort of audio apps. Things like latency, what kind of channel capabilities you have, how many frames you can render at once. There's bypassing. There's a whole bunch of other stuff which I haven't included here. You can look into it. It looks easy. And then you drop down a level. And I haven't done any C or C++ for maybe 20 years. Like, it's been a long time. But I looked into it. And I'm like, okay, you pull some audio off the input bus. You do some things with it. You find, like Marc was talking about, the vocal track, the synthesizer track. You process them. I'm like, you know what? That doesn't look that hard. Maybe I'll drop back up to the top level and I'll start reading some of the documentation. And I thought I'd start with a super easy one. You saw back in the previous slide, channel capabilities. You're like, okay, I'm just going to read the documentation. And I'm going to just breeze through this. Like, the array index alternates between input and output counts in ascending order of input-output channels, for example, 0, blah, blah, blah. And I'm reading this, I'm like, what on earth does this mean? Like, input channel, output channel, you can have positive numbers in there, you can have negative numbers. A certain pairing of negative numbers together means something. If you pair them differently, it means something different. And I was very lost. I'm like, I think I have 2 inputs, and I think you can have 1 or 2 outputs. I don't know, like it's stereo, so left and right. And at that point, I'm like, I am in over my head. Like, I've read the simplest bit of documentation for something that's not even that important. It's just reporting to the host what my channel capabilities are. And I'm like, I don't know what to do. I don't know what to do. So I've been talking to a lot of people younger than me, and they're like, oh, we do this vibe coding thing, and there's agents, and there's AI. And I'm like, all right, well, what the heck do I do? And the AI was like, you just put the numbers 2 and 2 in here. That's all you need to do. And I'm like, oh, cool. This thing must know what it's talking about. Like, I have no idea what to do, but I mean, it's written that code pretty badly. You don't need the whole get and the NS number and whatever. But I'm like, yeah, okay, we'll do that. And so 2 hours later, we actually had a vocoder that worked. It didn't sound any good. It sounded terrible. It didn't do what it was meant to do, but it was processing numbers. and it was producing output. And I'm like, oh, cool, we must be done. So literally, like, we vibe coded for maybe a day, and there was 3 check-ins and we were finished. And that was it. Like, there was no other check-ins. We didn't start in May. We definitely didn't keep doing updates. We didn't need to relearn what had changed in C++ in the last 20 years. We didn't need to learn all about Fourier transforms. We didn't need to learn about linear predictive coding. We were finished in like 3 hours. I think that's how it went, right? Yeah. No, as you can imagine, this is not what happened. I basically had to end up rewriting the whole thing. I ended up having to learn a lot about what a vocoder is, about what C++ has changed a lot. Let me tell you, they've got fancy stuff now. Yeah, you don't need null pointer ended arrays. You can have like proper arrays, and you can. It's pretty fancy. So how does our plugin work? Like Marc said, you've got a synth track and you've got a voice track, and you've got to process those 2 things together. But before you can do that, there's a few things that some vocoders do. And again, I'm way out of my depth here, so Marc can just jump in if I get any of this wrong. One thing you can do is called formant shifting. So that's where you make a voice sound deeper or higher than it actually is. And it turns out that's not as easy as it sounds. I'm like, you just ramp up one thing. But no, there's a whole bunch of things you have to take into account, because you don't want someone to sound like a chipmunk on one end. You don't want them to sound like really bad on the other end. So I tried ChatGPTing one of those, useless. I tried making my own, also really terrible. I tried again. I'm like, no, I can get this. This is just mathematics, right? It's easy. I couldn't figure it out. And in the end, I dug around and I found a really, really good open source library that someone had given at a presentation just like this at a different conference. And this thing was amazing. I plugged it in and I'm like, this sounds really, really good. So I'm like, cool, we got that. And then I spent time integrating into the project, only to realize that this thing introduced 200 milliseconds of latency into our pipeline. And that might not sound like a lot when you're doing programming, but when you're doing real-time audio, 200 milliseconds, that's way too long. So I had to spend a long time trying to configure all the windows for that, learning all about what formant shifting was, and basically modifying this open source code to get it down to something that you could actually use in real time. And we played with that a lot. We're like, okay, this sounds terrible, but we pump up these numbers a little bit. This sounds okay. This is acceptable. Anyway, then you do compression. You do a whole bunch of voice detection. So there's all these different, and again, this is out of my depth. There's all these different things people do with their throats when they talk. There's, you close your throat, you open your throat, you do all these different things. There's these things you can detect in a vocoder application. You replace them. You can do things like replace them with white noise or with a different sound to get like a better sounding robotic voice. So we eventually built all that in, and we're like, right, now we've got our voice and our synth. We combine them together using linear predictive coding. I believe that's what LPC stands for. We figured out all that maths. We're like, cool, we got it, and it sounded terrible. There was like a phase shift almost, and I'm not an audio person. I'm like, this sounds off. Like there's something very wrong with the way we've combined these 2 things. And I spent ages looking into the maths, and I'm like, you know what, the maths looks correct from everything I've read. I don't know what to do. And then Marc figured out one day that what we'd done is we'd mapped our voice track and our synth track just slightly wrong. They were just off by like a little bit from each other. And that was easy to fix once we knew what it was. We just put in a buffer for the synth track so that we could line them back up, and then you get your output on the other side. What does that look like in practice? You might be wondering where all the numbers go. This is the user interface that Marc created for the vocoder that we built. So you've got some dials where you can play with the level of voice input, the synth, the output. You can change the quality that you're doing. You can do the formant shifting sort of up and down. I think it's really cool. Marc's really good at user interfaces, so that's... And we even made a classic version. So this one was done by Marc again to imitate. You saw the picture of the DigiTech Talker, is that what it was called? Yeah. And Marc made this really cool thing that kind of emulates that. It's got 3 modes, and it's got the same sort of twiddly dials that you can play with. And yeah, and this is it sort of running in Logic as a plugin. And so you might be wondering, well, what are all the different things we did wrong? Well, one was that I was in a field I hadn't sort of worked with before, and I was relying on this AI agent to tell me things, and it just confidently made up everything. It's like, this is this is that. Oh, okay, good. But it just literally everything that it told me was completely incorrect. And I don't know if there's not enough source data, or if that's the general sort of nature of AI, but it was truly terrible. We had to sort of rewrite a lot of it. And it got me thinking about, we're kind of in this sort of period in tech where everyone's like, oh, your job's going to be replaced by AI and this thing's going to take over. And I'm like, is it? Is it though? Like, I don't know. And it got me thinking about, I'm going to embarrass someone in this room just slightly, but in a good way. I took over this code base about 3 years ago. Django, we're making a design tool. Some people say it's better than Figma. Some say it's Figma but different, but we're making a design tool for designers. But there was 5 years worth of code or more sort of in that I wasn't a part of. That was sort of before me. And it was by one of the giants in our industry, Mr. Tony Arnold over there. And it was, I got to tell you, if you've ever had imposter syndrome, you haven't really had imposter syndrome until you work on a Tony Ardle code base. You're like, I'm nothing, like I'm a small person, like what am I doing here? This is all amazing. And then I found this one class in there. It was like one simple class. It was only 400 lines of code, very small. And I didn't know what it did. It was just called compound solvable expression. And I'm like, oh, compound solvable expression, that's interesting. And I was I had to fix this bug in there, and I'm looking at this thing and I'm like, this thing is linked to every single UI component in the entire application. So if you imagine a design tool, you can make rectangles, you can make paths, you can do all sorts of other things. And you have to have ways to manipulate them in the user interface. So these things were all linked back to this one class. And this thing could edit any property on any object of any type. And it also responded to selection. So you can imagine if you're selecting things in a tree and you select 3 rectangles and 1 path, they're slightly different objects, right? But they have common properties and they have properties that are different. And this thing handled all of that. And it was even had functionality where you could take a slider and link it to a text box. So you imagine like an opacity slider with like a value next to it. It would link all that up so they're all dynamic. And this thing was magical. Like I have never seen a piece of code so elegant and so well crafted in my career. And I don't just say this to boost Tony up, but I say this that if you think about, I'm sure you could get 1,000 ChatGPTs or Claudes or whatever. You could give them 1,000 different inputs of all going backwards and forwards, day and day. You could give them 1,000 years, I reckon, and you would never come up with compound solvable expression. And I just think that says something. There's an art form to coding, and there's 400 lines of code that it was just, I mean, it probably wasn't perfect, but it looked perfect at the time. You're like, this thing is amazing. And I think I could have sat there with a ChatGPT and gone backwards and forwards, and I never would have come up with anything like that. And I think that's the cool thing about our industry, right? We get to make things like that. And maybe you only get to make 1 or 2 things like that during your career, but you look back on it and you're like, I made compound solvable expression. And the truth is, Tony's probably even forgotten that he made compound solvable. He probably has no idea what I'm talking about. It's still sitting in the Scala code base, and it is amazing. Every time I look at it, I'm like, wow, chef's kiss. Anyway, enough about Tony. So these are some other things I learned about plugins that I had no idea were things. You can load this plugin as many times as you want in a project. So you can have it on one audio track, you can have it on another audio track, you can put it somewhere else in the project. And I didn't account for that. I just linked everything together. I'm like, oh, this is cool. And then at one point, Marc had 5 of them in a project, and he moved one of the knobs, and all the knobs and all the things moved. And I'm like, that's cool, isn't it? That's really hard to do. And he's like, no, the knobs are not meant to move together. I'm like, okay, we'll do that again. The other one I learned about is in an audio plugin, you have these things called parameters. So you build a tree of parameters, and they're all the different things that a user can do with your application. So they might change the volume of the audio, they might change the quality, and you have to define all those down to the level of exactly what they are, because they're not just manipulated by your user interface. So this is a UI directly from Logic. You can tell Marc didn't design this because it's quite ugly, but functional. And this is where you have to specify, okay, the voice mode is this particular enum, it's got these 3 values, a UV level, it goes from -20 to 60 decibels. A formant shift has to be in semitones, and there's semitone sense, like a particular kind of semitones. And I had to learn about all these terms, and you have to define them exactly, because if you get them wrong, obviously other user interfaces aren't going to do the right thing with your parameters. And then I learned that there was more than one audio app. So at the time, I'm just using Logic, and I'm like, cool, Logic, we're done. And no, it turns out there's lots of other apps, and that looked easy at first because Apple does all the hard work of rendering exactly the same UI into, and so this is a different application, this is not Logic, but exactly the same looking user interface. And you think, oh, that's cool. But then you realize that other audio apps have completely different concepts about how you hook different things together. So Logic has the concept of a sidechain where you can say, I'm going to mute this track, but I'm going to plug it into this track. And in this case, the screenshot from Reaper has a completely different way of doing it. So you have to explicitly route this track to a different one. And what that means is in your actual plugin, things change. You can't have exactly the same audio code. You have to account for the tracks being in different places. And my code just crashed. That's how quality it was, because it just wasn't expecting this kind of input. So we had to do a lot of testing around that and fix that as well. And I will tell you, there's one other thing about audio testing that you don't get with UI testing. Like in UI testing, if something crashes, you're like, oh no, I get a stack trace. In audio testing, if you do something wrong, and I made the mistake of, I was wearing my AirPods at the time, and I got some of the audio wrong, and you just get really loud, crazy pops in your ear, and you're like, that legitimately hurt. So I learned, this is a top tip for anyone doing audio stuff. It's probably better to do on a pair of speakers. Don't put things in your ears the first time you want to test it, because it can be really loud. And I even broke the entire audio system on my Mac. I had to reboot the whole computer after I messed it up pretty badly. So that was no fun. But I guess what we're trying to say is that It's actually not that bad to try something new. You might make a lot of mistakes. We made a lot of mistakes. You might learn some things along the way. You don't have to rewrite everything you did it initially. Like if we look at the first version, we vibe coded together on that first day and we diff it with the final product. There's probably not a single line of code that's shared between those two things, but that's how programming works. Like that's fine. And I also learned how to do this properly. So this is the correct way to specify the channel capabilities for our particular vocoder. And I spent the time actually learning it. I'm like, okay, -1 means that you don't care how many inputs there is. -2 says you don't care how many outputs there is, and they also don't have to be matched with the amount of inputs. And then we do the same for the next 2 channels that we support. And I'm like, cool, I learned something. That's cool. That's not all we did though. We did some other interesting things. I keep saying we, but this is another Marc thing. So Marc decided to actually make a font for the project that we use called Rocket. And he'd never made a font before. I'd never actually included a custom font in an application before. It turns out that the making the font might be hard, but the including the font is really easy. So if you've got designers that you work with or you are a designer, yeah, I encourage you to try putting your own fonts into your apps and kind of give them a bit of personality. It's actually the font that we've been using for all the titles in this presentation, I believe. It's just a cool font that goes with the project. And one more thing. I thought maybe we could actually give you a demo of what this sounds like once you've all put it together. Yeah? Everyone wants to hear that? Let's do it.
Hello, this is Robot Rocket. It for codes and you cannot stop it. It's the sound you once knew. Now it's sharper, cutting through. No more waiting, no more luck. Turn the dials and light it up. Hello, this is Robot Rocket. Hello, this is Robot Rocket. We're flying on a rocket. We're flying on a rocket now. We're flying on a rocket. We're flying on a rocket now.
Thank you. That was actually Marc singing, by the way. Yeah. No, I'm being dead serious.
Should have done it live.
No. Not good enough for that.
Well, that was fantastic. Thank you. Any questions? We've got plenty of time for questions. Louis.
Are you two actually Daft Punk, and is the face reveal right now?
It is.
What's the final latency you achieved?
For the format shifting,
That is a good question.
20 for the entire plugin, actually, 20 milliseconds.
Yeah.
Yeah. So it's the thing about audio plugins is you don't realize this as a regular programmer, but it's not about how much CPU time you use and how long things to process. It's actually you have to have fixed amount of latency. So you have to have a fixed amount of input latency, a fixed amount of output latency that you can guarantee that you can get there in that time. And that's what you report back to apps like Logic. So yeah, ours ends up being 20 milliseconds, which sounds a lot better than 200.
It does. Yeah, 200 is completely unusable if you're trying to use it live. 20 is pretty decent. So yeah. Yeah, and it's also, I mean, the thing is, it's quite difficult. The actual hardware also has reasonable latency. So that's a normal thing that people who have used the hardware have had to deal with as well. So yeah, but 20 is pretty good.
I'm not too familiar with how audio plugins work on macOS. Is this an OS level thing, or is this something you made for a specific audio processor like Ableton or something?
There's all these different plugin architectures. So A Audio Unit is one that Apple made. And that works in Logic, works in Ableton, it works in Reaper. I think it might work in a few other apps. But there are other plugin standards as well. So there's one called VST3, I think, that works in a lot of different apps. There's one called Clap, that's like an open source one. I love in the audio world that I heard that's a more modern plugin, but it's actually 12 years old. The format's 12 years old, but it's more modern. Like, whoa, let's not get too crazy. But yeah, and it's the processing that you do is the same in all of them. So we have like a C++ library that just does the processing part that's cross-platform. But then the plugin bits where you're extending AU Audio Unit and everything else, that's Apple specific. And so the other plugins have their own format. And so what happens is the host application loads that plugin using that sort of framework, and you can have as many plugins as you want from as many different sources. because you want they all kind of load into one project.
Yep. There is one thing to note though, it doesn't work in GarageBand. And the reason for that is GarageBand doesn't support sidechains. So it's sort of a pro-ish feature. And we just need it for a vocoder because you need 2 inputs. So there's no way to really make it work in GarageBand. So even though you can load AU plugins in GarageBand.
So I guess in a similar segue on that note, so I do a lot of editing in Final Cut Pro. Just wondering from a plugin point of view, is that something that could work fusing input of both vocals as well as some sort of audio track?
I mean, are you asking if it works in Final Cut? I think Final Cut supports audio plugins and it should work. The sidechain thing I'll have to look into. It may not support sidechains because again, that's sort of more of a slightly stranger pro audio thing rather than something would do. But yeah, so it should. I mean, it should. The thing is, it just should work everywhere that supports AU plugins.
Just a more vocoder question because I've never known how they're used.
Yep.
Is the synth tone a single pitch and then you use your and then you pitch with your voice, or do you maintain a single pitch with your voice and move it around?
So the awesome thing is it uses the synth. So it's the pitch comes from the synth input, which means you don't need to be able to sing very well, which is why I was able to make the demo.
But you kind of maintain a monotone, or I mean a single pitch, or do you?
So the synth can be anything. In fact, the floaty bit, whatever on a rocket, that was done playing chords. So that's actually that's 3 notes at once in the synth, 3 notes, and the vocal is actually identical for that. And you can just speak. So Kraftwerk used vocoders a lot. In fact, they used the Sennheiser model a fair bit as well. And yeah, you can just talk and you can play, and so the pitch comes from the synth input, and yeah, the vocal doesn't have to be pitched.
Is there a thriving marketplace for audio plugins for all these various bits of software?
So strangely, it's a good question. Strangely, the prices didn't sort of collapse and end up, going to zero like they did for a lot of other software. And I have no idea, but we haven't launched this yet. I don't know how well it's going to go. We're going to price it reasonably cheaply. But it seems like there is actually quite a lot of small companies making a lot of plugins that do cool things. So I think the answer to that is yes. I mean, it doesn't mean we're going to succeed, but I think the answer is yes, there is a thriving ecosystem. And I use a whole bunch of plugins where there's like a single developer who's made it. And yeah, I think because also they can be quite small. It's a project that a single person can easily make themselves if they're really passionate about something. So yeah, I think the answer is yes.
And a follow-up, after you do launch this, are you expecting an email, angry or otherwise, from Daft Punk?
Well, we're not going to mention them at all in the marketing material. And we're probably not going to mention the actual model, even though we didn't copy anything. It's just the technique, and the technique is not the company that made. It's not DigiTech's technique that was that linear predictive coding is something that was built for telephony. It just so happens that it also can you can make a vocoder with it.
Were there any limitations in the framework or things you wish it had?
You're talking about like audio unit framework?
The framework you were using for creating the plugin.
Yeah, so I mean, Russell might be able to speak about this more, but I'm just going to mention one thing. So we said we built it as an audio unit version 3 plugin, and that's actually fairly interesting because most plugin makers don't make audio unit version 3. Version 2 requires an installer, and it goes into your system folder somewhere. Version 3, it's actually inside the app bundle, and that was done because I assume Apple did it, so that means you can have plugins on iOS. And so we decided just to go for latest and greatest because you don't need an installer. It means you can have an app that can auto-update as well. We can do a whole bunch of extra cool stuff. You just sort of download it and just put it in your applications folder and just magically works. In terms of other limitations?
I think the main one is if you want it to be able to work on other platforms, if you actually want to support some of the other plugin standards, then you can't use, for example, Apple's Accelerate framework, and you can't use some of the other stuff that might not be on Linux or Windows. So you kind of have to keep that in mind, that you're processing numbers, but you can't use libraries from the platform that you're processing on, unless you want to be Mac only. And in this case, we were thinking, yeah, maybe one day we'll make a Windows version, or
yeah, we'll see how it goes. We're just going to launch it as Mac only, audio unit only, and if enough people ask for it, then maybe we'll try to do something else that we don't know how to do.
But the framework itself actually doesn't provide a lot of ways to do things with audio for you. It's just a way of getting the audio in and out of your plugin, basically, and all the UI sort of associated with that, and all the parameters and things.
Brilliant. That was awesome, guys. Thank you very much. Please thank Russell and Marc.
you.